So coming to the next topic, single phase AC supply is given to pure capacitor. So supply voltage V is equal to Vm sin omega t. This is the instantaneous value of the voltage. The current through the capacitor is IC is equal to C dV by dt. C into d by dt of V max sin omega t, and d by dt of d theta of sin A theta is equal to A into cos A theta, and C into Vm into d by dt of sin omega t is omega into cos omega t. So x can be written as 1 by 1 by x. So V max into omega c can be written as V max divided by 1 by omega c and into cos omega t, where xc is called the capacitive reactance. And xc is equal to 1 by omega c, and that should be equal to 1 by 2 pi fc. If the frequency value is 0, the xc value is infinity if you draw the curve between frequency versus xc. As the frequency increases, the capacitive reactance decreases exponential decay. And P max by xc cos omega t can be written as sin of omega t plus pi by 2, that is 90 plus theta. So here I is equal to I max sin of omega t plus pi by 2. In this case, V max by xc can be written as I max. This is the instantaneous value of the current, or I is equal to I max cos omega t. If you want to draw the instantaneous power waveform, you should substitute these values on the waveform. At omega t equal to 0, as V max into sin 0 is 0, I is equal to I max, and the instantaneous value of the power 0 into I max is 0. At omega t equal to 45, as sin 45 is 1 by root 2, cos 45 is also 1 by root 2, and the power is equal to V max I max divided by 2. So root 2 into root 2. At omega t equal to 90, S1 is positive maximum and another one is 0, and the product is 0. So if you draw the waveforms, so this is the voltage waveform I am drawing for one cycle. So the voltage waveform you should draw like this: 0, 180 and 360, and this is 90 and 180, plus 90 is 270 degrees, so in between 0 to 90 we have a 45 degrees, and this is 135, 225, and this one is 270 plus 45 is 350. See, at omega t equal to 0, so 0, yes, 0 magnitude 0, 90 is maximum, 45 have some magnitude, 135 have some magnitude, and this is the sinusoidal waveform, instantaneous value of the sinusoidal waveform. So coming to the current waveform, that is cos waveform, I is equal to I max cos omega t. I is equal to I max cos omega t. So at omega t equal to 0 is I maximum, at 90 is 0, 180 is I maximum minus I maximum. This is a 270 is 0 and 360 is positive maximum. So this is a instantaneous value of the current waveform, instantaneous value of voltage waveform. At 45C, both are having the same magnitudes and both are positive. At 135, one is positive, V max by root 2, this is V max by root 2, and this is minus V max by root 2. So first mark the 0 positions, 0 here 0, 1, 2, and this is 180 is 0, 270, one of the waveform is 0, 360 is 0. So if you multiply any quantity with 0 is 0. In between what will happen, you can see positive into positive, yes, V into Im by 2 at 45 degrees, yes, you have some magnitude, that magnitude is like this. This one is 0. At 135 you will see one is positive and another one is negative. So obviously power is minus Vmax Imax by 2. Set this position. So this is a waveform. At 180 it will be 0, and here both are negative. See here, negative into negative, 225 degrees, both are positive. So negative into negative is positive. By joining all these values, then I am getting the power waveform is like this. This blue line is for the instantaneous power waveform, and when the voltage waveform completes one cycle and the power waveform completes 2 cycles, then the average power is equal to 1 by pi integration of 0 to pi instantaneous power into d omega t. 1 by pi integration of 0 to pi. What is the instantaneous power? The instantaneous power is equal to voltage into current, instantaneous value of the voltage into instantaneous value of the current, Vmax sin omega t into Imax cos omega t, Vmax into Imax sin 2 omega t by 2. So Vmax Imax sin 2 omega t divided by 2. So Vmax Imax by 2 pi, integration of sine is minus cos 2 omega t, 0 to pi, and take a minus sign is common, and substitute the upper limit and lower limit. 1 minus 1, you will get this 0. The average power through pure capacitor is 0. If you draw the phasor diagram, I am taking the voltage as the reference, and the current is omega t plus pi by 2. The current through the capacitor is 90 degrees leading.